Every day, the future's getting closer.
Welcome to Master the NEC, where we talk about the National Electrical Code and all things electrically related. My name is Paul Abernathy, your host, and welcome to today's podcast. Well, hello everybody. Welcome to another episode of Master the NEC, where we talk about the National Electrical Code. My name is Paul Abernathy, your host, as always, and welcome to the podcast. On today's episode, we're going to try to keep it brief, and we're going to simply, and I know that's a challenge for me, y'all all have listened to my podcast before or watched my videos, and every time I say it's going to be brief, an hour later, I'm still talking about the subject. I get it. I can't help it. And I acknowledge that I can't help it, okay? The first stage of fixing the denial is to admit it, and I admit it, okay? So, I am on a 10-step program to reduce my videos and times of my podcasts, and I'm not doing real well on my 10-step program. Anyway, so today we're going to talk a little bit about THHN, THWN-2. I know it seems like a very basic topic. Everybody knows by now THHN and THWN-2, right? Everybody knows where your uses are for that. So it's obviously, I can't help but say it's going to be a short one today because you should all know what that is. And so I want to just talk a little bit about it and kind of dispel some things that people ask about, especially the nylon and things like that. Okay. All right. So let's talk THHN. THHN is a heat-resistant thermoplastic. Now, it is malleable based on the temperatures that it's exposed to because it is a thermoplastic material. Okay. And when you're dealing with the insulations, typically in the building industry, you have two types of insulations. You have a thermoset, which is exactly how it sounds. It's temperature driven to a set temperature, and it doesn't get malleable. In other words, it doesn't have an issue of melting. Now, it can get to a point where it can crystallize and dry out, but it really doesn't melt down because of the cross-linking effect that takes place, and it's a chemical process. Whereas thermoplastic, when you get to a certain temperature, it will melt. It will start to sag. It will start to deform. Okay, now both the thermoset and the thermoplastic, for all intents and purposes for us, in dealing with the electrical industry, it's 90 degrees C. Now that's not to say that some of the applications under some other applications for appliance wire, appliance machine wire, or maybe under MTW or something where the insulation can get up to 105 degrees or even higher, but that's based on its application and where it's used and different listings that you have to go for that. So we're just talking basic THHN, THWN-2. So typically it's a 90 degrees C. Okay. Now, when you think of that 90 degrees C rating of that insulation, which mind you, thermoset and thermoplastic, THHN, THWN-2, and the most common cross-linked polyethylene would be XHHW-2, for example. Of these two, they're both still rated 90 degrees C for their insulation, okay? Which is why we do adjustment and corrections from the 90s so that we know that under their condition of use, they won't exceed the temperature rating of the insulation. So we have to actually drop the amount of current it can carry depending on whatever condition we're dealing with in order to keep that potential temperature, both ambient and internal to conductor current flow, to keep that ultimate temperature from reaching the point where it can cause problems to the insulation, right? Whole different story. Go watch that D-Rating Demystified and you'll understand how to do adjustment and corrections. Not going to get into that today. All right, so let's just talk about THHN for a second. All right, one T. So in THHN, the T is for thermoplastic. The two H's, I like to think of it this way. When you see one H, it's heat. When you see two H's, it's high heat. So if you have one H, it's 75. You have two H's, it's 90. It should be a dead giver. It's not always the same for cross-linked polyethylene, and I'll explain that briefly in a second so it doesn't throw you. But typically when you see the two H's, we're dealing with a 90, one H is 75. If you see no H, like a TW, for example, then that's 60. Okay, there's no H present. All right. Now, the only exception to that rule is XHHW. Now, XHHW, cross-linked polyethylene, when you see XHHW, you see two H's. So in your mind, you immediately think, well, two H's, it's 90 degree. Okay? but that is not the case when it comes to the wet location. It's still 75. In the dry location, it's 90 degree. Okay, so that's probably one exception to the general rule when I tell people about that, and I say just remember the H's and all that kind of stuff. And one way to verify that is if you go look at 310.15b16, and you'll look and you'll see XHHW, it actually falls down on the 75 degree column, but you'll also notice that over here in the 90, that it also is an XHHW under the 90 degree column as well. But that's just actual usage. So what happens if you go look at the code and now you go to, I believe it is 310.104A, which reminds you all this is going to change in the 2020 code, by the way. And you go look at it and you look at XHHW, you'll see that normal XHHW, again, is 90 for the dry and damp, and it's 75 for the wet. Okay? But then you'll notice under the XHHW-2, it's 90 wet and dry. So while it's listed under both, remember that you can always quantify that by going to table 310.104A and seeing what the applications are. And again, XHHW, dry, 90, and damp, and wet, it's 75, unless it has the -2. So how it's laying out in 310.15b16 can get kind of confusing. So just remember that normally 2 H's is always going to be 90, but in this case where you see XHHW, know that it is 90 for the dry and damp, but it is still only 75 for the wet locations, and you need the -2. Okay, so hopefully that doesn't confuse anybody. So that's why I'm going to totally get off of the XHHW cross-linked polyethylene and get back on today's topic, which is THHN, the thermoplastic material, and talking about the nylon, because that's the question that I got emailed to me, and they asked me to do a quick podcast on it. And as I tell you folks out there, if you have topics that you want me to do things on, just send them to me and I'll try to do a topic. I've got a bunch of them in the queue. In fact, this one right here is a couple months old, so I'm just catching up to these list of podcast requests. And then I get video requests, but I seem to get more podcast requests than anything. I guess people like listen to the podcast. So anyway, let's talk about this now a little bit. So THHN, so the T is thermoplastic, the H's are high heat in this case, and the N, since there's no W, we know it's a dry location, or in this case also a damp location. Again, you can always verify that by going to 310.104A. And you'll notice that it says 90 degrees C or 194 degrees Fahrenheit. We typically usually work in C for Celsius most of the time when we're working in the code. And it says dry and damp locations. Flame retardant, heat resistant, thermoplastic. And of course it gives you the sizes in AWD 14 all the way up to 1000 kc mil. And the typical mils or thickness of the insulation. Then the last thing you'll see in that column is called outer covering. Okay? Now, outer covering is applied over top of the insulation. So there's two ways to think about this. When we make a THHN, okay, and of course THHN is also THWN-2. We'll talk about that in a second. But thinking just THHN, and most people don't make just THHN anymore because it has a very singular type of use inside of buildings and raceways because it is a dry only. So it couldn't be used, well, I say dry in a damp, but it couldn't be used in wet locations. So you create what's called multiple SKUs, and most manufacturers don't like to do that. So if we can approve one product and it will pass under another test under UL 83 and then of course UL 2556, which is the testing standards, then why not dual rate it? So that's what most all of us do. We'll dual rate the product. So in this case, THHN is THWN-2. But let's focus back on THHN. So we have the two H's, high heat, that's in a dry location, and of course damp also, but we'll talk in dry mainly here. And then the N stands for nylon. Now a nylon or equivalent, because it might not be nylon jacket extruded over it, it could have something that's equivalent to the nylon that's acceptable to the standard. Okay, so let's talk about this nylon. So how does it get on there? How does this happen? There's two ways of concepts to think about this. So when you run a line, I get people ask me about the copper. Okay, let's just talk copper today. So I have copper, and we bring it in, like in our facility, we'll bring it in cathode. Of course, we also have a robust recycling program where we'll take in ETP copper, electrolytic tough pitch copper, which is the more refined, not refined copper. This is a higher grade copper, electrical grade copper, and I think 99.9% pure. And then when you bring that in, we will actually mix it with the cathode, and it'll go down to our vertical furnace, and it'll come out in a continuous casting. And then it goes, and we'll draw that down into rod, and then the rod goes over to our drawing machines, and the drawing machines will stretch it out based on the different dies, and we'll actually bring it down to the actual size that we need, and that's called American wire gauge size, the old Brown and Sharp. It brings it down through a various number of dies to get it down to this size that we need, and then it goes on to insulation. So when it's copper and it's in the mill form and it goes into the rod, all that's pretty much governed under something called an ASTM standard. I do have people ask me all the time is, what is your UL standard for bare copper? And there isn't a UL standard for bare copper. That's an ASTM standard. Now, once it subsequently goes to get insulated, and if it's insulated, then it gets utilized in a cable assembly of some sorts, then we have a various number of Ansi Ul standards that we have to construct it to. And that's going to tell us the insulation thicknesses as a minimum, as well as an average. And we're going to insulate it and then subsequently take those insulated conductors and use them individually, put them on reels, or we're going to put them in a cable assembly and then sell that cable assembly. And that has its own UL standard for the cable assembly. For example, MC cable is UL 1569. It's going to tell us what conductors we use in it, whether it's thermoplastic or thermoset, and it's going to tell us the length of lay and how we plex it, and then put it inside the cable assembly and how it's constructed, and then we will produce it, and that's got its own UL ANSI standard. Okay, so going all the way back, that's the ASTM that deals with the copper. Once it starts getting insulated and put into cable assembly, that's when the UL ANSI standards kick in. And for THHN, the UL ANSI standard is a UL 83. And the UL 83 is going to give us a bunch of guidelines for the weight, the resistance, all these type of things. And of course, we have testing procedures. It's going to reference UL 2556 as well, which is a testing standard. And we're going to do things like elongation and cold bends and all this other good stuff. And UL comes into our facility. And UL, the one that comes into your facilities, that's a third party NRTL, Nationally Recognized Testing Laboratory. Now, there's a bunch of them out there, and they're all pretty much equivalent, but we use UL, and so they're probably the largest. So it's different than the UL ANSI standard that was used to make the product. We all have to follow that. What happens is the NRTLs come in, and it could be ETL, Intertech, it could be FM, it could be a bunch of different ones, and they will verify that you made the product to the original UL ANSI standard. So while the UL third party is separate, and sometimes people get confused thinking they're part of the UL 83 standard, it's two different things. They're a third party. They're just looking to make sure you made it correctly, that you put their stamp on it correctly, that you put the markings ever so many feet and things like that. That's what a third party does, okay? And then once we meet their satisfaction, and they're constantly checking the wire, and they do what's called outside testing too. It means that they'll go to a supply house and pull samples of your wire somewhere out in the industry to make sure you're conforming to the standard. And that's perfectly acceptable because we all want to make sure that we're at the top of the standard because it's all about safety. Anytime you use Encore Wires products, our main focus is the consumer safety. That is one of the things that drives us. So that quality is something we always have to think about because it's not just about us making wire. I mean, we make wire 24/7, 3 shifts every day, constantly turning out wire. But we have a robust team of QC folks that constantly are pulling samples and weighing these samples, doing elongations, checking the bends, checking the way the product looks, the way the markings are on it, things like that. And so at the end of the day, it's a very detailed, very costly process to make sure that the wire that makes it to the market is safe. And that's what it's all about, getting the product out there safely and the quality remaining very high. Again, doesn't matter who you use. Generally, all the manufacturers that are in the U.S. should be in that same mindset, that same focus of how they're producing the wire. Okay? And see how easy it is for me to get off topic. Okay, so once it gets out of the process where we're drawing it down, and then it gets to what's called the lines for extrusion. So then we load the copper wire onto the actual reels, and we bring it into the extruder, and we run it through the extrusion process. Now, there's two types of extrusion. You can have the extrusion where it extrudes the PVC material onto the conductor and simultaneously also puts the nylon on it. Okay, and that bonds pretty good because it's at the very close to the same temperature, so they bond very well and adhere, so you don't have that much separation from the nylon from the insulation. And then there's another process where it's subsequently nylon's applied. It means it goes through the extruder first for the PVC material, and then almost immediately goes through a separate extruder for the nylon. Now, a lot of people do it in two stages like that because it's less chance of a mess up in the process where maybe one starts putting too much out and the other one, and it can cause a problem. So if they put them really close together, it's kind of, in some cases, can be a very much easier control process. But anyway, that's what you're doing. And immediately after that, it gets thrown into a cooling trough, and that's where it cools down. And then ultimately it goes back onto reels, and then it's used in other cable products. Okay. And of course, the printing takes place right there once it goes past the nylon extruder or whatever the combination extruder was. And exactly what it is, it takes these pelletized material and literally under pressure and heat extrudes it out, and it just simply vacuums it, and it adheres to the copper as it goes through the extruder machine. Okay, and so that's how we make it. It's all monitored, cameras, very expensive equipment to maintain the thickness of that insulation. And you have minimum thicknesses that you have to meet based on the standard, and these machines are dialed in. So usually when they're starting a run, they have to run, some cases a couple 100 feet in order to get that machine dialed in. And then they have the machine will mark it, and then that first part of the run will get discarded, and we recycle ours. And then you get the good wire, and that's once the machine gets dialed in, then that's when the operator notifies the machine, and that's when the wire that you get as the end result, and that is that purely very safe, well-made wire. Now, THHN, that nylon. Now, that nylon that gets extruded onto the thermoplastic material, the nylon is there for a couple reasons. One, it protects the insulation. So the nylon is not insulation. Okay, that's a fallacy that people have. They see the nylon chewed up during the pull or whatnot, or maybe they're in a location where the temperature was at a temperature where the nylon was cracking or whatnot. That's perfectly acceptable. The only exception to that rule is if you know you're going to be installing THHN in an application where you have oil and gas exposure. And if that's the case, then the nylon has to stay intact. All right, and you'll notice that the markings on that will be a GR or a PR1 or 2, depending on the testing that's done on it for that environment. And that lets you know that it's acceptable for an oil and gas environment. Now, for all other purposes, that's not necessarily, because what we do is when you're testing this product to meet the UL standard, you actually have to take the nylon off. So when we do the water test or a long-term insulation resistance testing and all the things that we have to do as a manufacturer, we're actually testing without the nylon on it. Okay, so that should tell you right there. It's not necessary to have the nylon on it for that application. But in the field, if you happen to run into some THHN or THWN-2 or any of the products that have a nylon covering on it, and it's not an oil and gas environment, it's just a typical normal environment, then the nylon is itself sacrificial. It serves a role as protecting the insulation during the install process, because there's a lot of 90s, a lot of friction. It also allows for the pulling lubricant to stay onto the nylon a little bit better, so it helps reduce that friction. And also to remember that if it gets to the end and it's cracked up, that it served its purpose. It helped you get the pull done. It kept from damaging the insulation, and it was sacrificial to the fact that it was just there as a protective medium. Now, most of us manufacturers will actually put the required marking information on that nylon. So I've had inspectors call me and say, well, I can't accept your THHN because I see no markings on it. Well, I usually will say to them, did you go to the other end of the raceway where the pull started? And they say, no, I didn't. You go to the other end, you can see the markings fine. And I'm like, also, if we're telling you it's our wire, we're standing behind the warranty, and we can give you a cut sheet, data sheet, or a bill of sale laden that shows that it's our wire, then you really shouldn't worry about that aspect of it. As long as you know that it's THHN or THWN-2. And we can provide you with enough, and the inspector can find that on the other samples on site or the reel that it came from, to understand that the markings are there to make sure that we conform to the standard during production. And we did that. And it was evaluated there by the inspectors, and it's evaluated at the time it arrives at the job site, and you're able to see that you've got the right size wire, the right AWG, everything that's on it that says what it is, and then you install it. Things happen. UL will tell you, Underwriters Laboratory will tell you that they don't govern the installation once it's installed. Okay? It was verified to be the right wire because you chose to use it and you installed it and it was compliant. But there are more than enough ways to find the markings on that wire. That's why we're required to mark it every 2 feet, because it's not the only place to find it is right there at the termination at the end. There's other places that you could find that. Other junction boxes at the start of the run, reels that are there. There's other ways to do it. So you can agree to disagree if you want to take a hard line on that. That's up to you. But the reality is, all you got to do is go back to the testing and notice that we have to pull off the nylon in order to test it to make sure it's compliant. So nothing in the standard says that we have to apply the markings to the insulation and then subsequently put nylon over it. Okay? Nothing says that. If you want that, you're going to have to fight to get that changed in the standard. And then good luck with that. So the reality is most of us will print it on there because it's very hard because of where you put the insulation and where you put the nylon at the temperatures that we're dealing with. It's very hard to get the markings on it. Now, that's different for a cross-linked polyethylene because you have one extrusion. It's just one insulating material. And then once it comes out, it cools enough after a foot or 2 or 3 in order to be able to put those markings on there. That's totally different when it comes because of the adhesion requirement. In order to be able to get that nylon to adhere to the actual insulation, then it's very close proximity and it's very hard to put the markings on it that way. Okay? I'm never going to say impossible, but it is very hard, and most manufacturers aren't bound to do that. They're not going to do it. So we simply put it on the nylon, and for decades, that's been acceptable. And of course, you can call somebody like me, who's head of a Codes and Standards division, and I'm going to explain that to you, give you all the warranties, write you a letter, whatever you want, saying, yes, sir, that is our THHN, THWN-2. Yes, the nylon doesn't matter. Yes, you can go find the markings on it. We'll even show you the bill of lading from the sale saying that is that wire. In fact, all of our wire has markings on it to tell you who made it and who inspected it. It's all right there on the wire. So we can actually date it all the way back to when it was produced. Okay, so, and in any given time, usually you can go to the very beginning of the pull and that wire's insulation is perfectly intact and you can get your information right there. Okay, so anyway, nylon, sacrificial, except for an oil and gas environment. And you'll know when you're dealing in an oil and gas environment. You'll know the difference, whether you're in Article 500, 501, 502, whatever. But normal installations, nylon is sacrificial. It does help for the pull. So kind of remember that. Now, THWN, again, noticing that that's THWN, it just has one H, so it's 75 default. It is okay for a dry and a wet location. But even in a dry location, it's only good for 75 because it only has one H. Okay, but because we add that -2 onto it, that's what the -2 means. Then it's good for 90 degrees in a dry or wet location. Okay, and really what that's telling me is that it is where I can install it starting at the 90, and I've got to remember my terminal limitations for whatever I'm terminated to, but at least I can start at the 90. So again, if you don't know what that means, you need to go watch our derating demystified video to get a better understanding. Just go to our YouTube channel, search for them, and you'll be able to find it. All right. A couple other things that are different, then you'll notice that the thicknesses of the THHN and THWN-2 are exactly the same. That's because that product usually gets dual rated, and so the thicknesses and mils of insulation stays the same. Both, again, it's the same theoretical product. It's just evaluated 2 different ways for use in a wet location and in a dry location. Okay. Now, a couple new products that have come out, I shouldn't say new, but they're actually first listed in the NEC, was THHN, which is a cross-linked thermoset product, but it does have a nylon covering as well. Most notably, probably helps reduce the coefficient of friction with that nylon. And then, of course, you have the THWN as well, and that also has a variant in the -2 as well. and that also has a nylon jacket on it. So it's not just thermoplastic now that will have a nylon or can have a nylon covering or jacket on it as well. Okay, and it also says nylon jacket or equivalent. There's other stuff out there that is equivalent to nylon, like a Teflon type of covering, all those type of things that could be argued that is equivalent, okay, to the nylon jacket. All right, so you'd have to look at the standard. And again, when we're dealing with THHN, THWN-2, we're looking at UL 83. If you wanted to look at the thermal set requirements, then that's UL 44. And that has all their requirements in there for the thicknesses and everything like that when it comes to the thermal set. All right. Well, that's just kind of an overview. Answer that question for the gentleman. Try to do it in under 30 minutes. The nylon, again, really beneficial, protecting the insulation. It's great to lower the coefficient of friction for use also with any pulling lubricants or in conjunction with products like ours, which is a Super Slick Elite, which actually is applied to the product prior to you receiving it, and it has a long-term staying value on there. It stays on there a very long time. And of course, when you put it on a reel, it kind of protects it as it goes deeper into the reel. So that stays there. It doesn't evaporate out. So that's always on there. You don't need to use additional pulling lubricants, although you can if you want. If you want to use more pulling lubricants, go for it. I usually tell people don't go crazy because using too much pulling lubricant can cake up due to friction during the install, and it can actually work against your friction and can actually raise your coefficient of friction. But using the right amount, and nobody wants to waste anything. We like the polywater stuff. We think that's a great pulling lubricant to use. It's not overly cakey. It's more of a liquid type of pulling lubricant, a gel, and it works really good. But again, use whatever your flavor might be. I always recommend pulling lubricants. When you start getting in conductors that are going to be 250 kc mil and larger, even though it has pulling like a Super Slick Elite on it, or some other manufacturer might have something on theirs or something that emulsifies out of it, it doesn't matter. When you start getting into those weights of 250s and larger, it doesn't hurt to add additional pulling lubricant. Now, you're not required. It will pull fine, but I like to do it. I'm old school. I might add some extra to that, but don't feel that you can't or that you shouldn't. You can if you want. You don't have to do it. It's as a manufacturer, we'll tell you that's your choice. Okay, we put enough on there that will work fine to give you about the 0.17 to 0.18 coefficient of friction for those that are doing a pull calculation. That's a happy medium because sometimes it can be a little lower, sometimes it can be a little higher. We don't know the conditions of use, the contamination of the raceway, whether it's rigid versus IMC versus EMT versus PVC versus whatever you might use. It can change a little bit, so we kind of take the middle of the road. And also, just to remind you, in pull calculations, do not negate the incoming tension. That can play a huge role. If you let that incoming tension get too high, means you're not helping feed this wire in, and it starts to kind of jerk, then all of a sudden that coefficient of friction goes out the roof, and that's where you get things like sidewall damage and elongations of conductive material and all that kind of stuff that you don't want. Okay? But if you're making a pull calculation and you're using Encore wire products, give us a call. We'll do that calculation for you. Just some forms you got to fill out, and we will give you a second set of eyes on that if you need it. Okay, we don't have a problem helping you out at all for that. Or you can call me personally. I do that for other companies all the time if you have a pull calculation that you want assistance with. If you don't know how to do it, we have no problem doing it at all for you to help you out. All right? So remember, that nylon, sacrificial unless you're in an oil and gas environment. If you have any other questions like this or you want a podcast, please feel free to give us an email at info at masterthenec.com. And I'm more than happy to put you in the queue here and do an podcast or a video if I think it's worthy of a video whenever I get the time to do it. So until next time, stay safe, folks, and God bless.
Every day, the future's getting closer. Every day, the future's looking bright. Every day is another beginning.